Assalamu alaikum. Welcome to the video tutorial, and in this discussion with this video we will know about the Tower of Hanoi problem, which is so much complex and common problem in data structure. And this problem are taught in everywhere, most of the universities. So most of the students of universities will have a helpful informative sessions with this video. So what is Tower of Hanoi? A Tower of Hanoi is a mathematical game or puzzle. It consists of three rods and a number of disks of different sizes that are arranged in ascending order and needs to transfer the disk from one rod to another rod. That's the graphical view we are seeing in the GIF file. And what is the goal of this Tower of Hanoi problem? Our goal is to move all this from the first disk, in fact the here denoted as a source disk, to destination disk by using an auxiliary disk. So this work should be done by some rules. So what are the rules? The rules are about only we can only one disk can be moved among the towers at any given time. So we cannot move two disks at a time. That's the rules. And two or more disks at a time. So only the top disk can be removed. So at a rods, which disk in at the top position, we can just move this from disk to another disk, and no larger disk can sit over a small disk. That is the rules of to solve this problem. So let's take an example for 3 disk. So in 3 disk we can solve the problem with this approach to move the all the disk from A to C. So what are they? So first of all, we can move a disk from we can move a top disk from rod A to C, then shift second disk from A to B, then thirdly the shift first disk, again shift first disk from C to B, shift third disk from A to C, and shift first disk from B to A, and shift second disk from B to C, and shift first disk from A to C. So thus we can solve this problem. So have you seen any patterns in the shifting method? I think you will get it after the rest of this video tutorials. So do not worry, it's just beginning. So we will know about further information with the problem to how to solve it, and we will give a algorithmic knowledge to yours that will help you to understand these topics so easily. So here we just seeing the pattern that we are doing some work repeatedly, like the first disk move from A to C, then second disk from A to B, and this then again first disk from C to B, and again A to C, and B to A, and B to C, and A to C. So there has a pattern. So what will be they? We will know. We will know. We will have a clear idea after the following slides. So what? So let's. We will take another way to understand code. What are happening in the code session. So let's explore the problem with so much complexity to know about the problem uh, well. So if we have about 4 disks for complex 4 disks, how we can solve this. At before we have solved the 3D's problem, and the 3D's problem, and if we want to solve the 4D's problem, we have to call that we have to solve we have to first of all we have to solve the 3D's problem. And if we have to solve the 3D's problem, we have to solve the 2D's problem. And that's will and this recursive call will call again and again after, until the until the n will be the 0. So so with this procedure we can solve any number of problems, any number of disk. So uh, oh sorry, I have forgotten you to tell that there have a minimal movement we can do. If we there has so many tricks to solve this problem, but if we solve this problem correctly, we can solve this problem with minimal moves. So with 4Ds the puzzle can be solved in 15 moves, which we will see at a little bit after. And that's so is there any pattern that is there any pattern we see here? Yes, there has a pattern, because the 15 moves that equals to 2 to the power n 2 to the power 4 minus 1, because 2 to the power 4 is equal to 16. And if we subtract 1, then the 15 moves will come. So we can say that the minimum number of moves required to solve the Tower of Hanoi puzzle is 2 to the power n minus 1 moves. So let's see how the recursive procedure of Tower of Hanoi, how it works with these problems. So here we will see about 4Ds to know this problem very well. So when we have called the Tower of Hanoi 4 disk ABC function, what will happen? It will just split into two parts. One part will have we already have a scene into our coding hint that there has two functions. First of all, the first function is called the n minus 1 ACB, and the second function are called n minus 1 BAC. And the middle of this function we are doing a uh, print message. We are doing a print message. So if we call a Tower of Hanoi function that's n is greater than 0, that will split into two parts. One is n minus 1, and this function will contain the swap of the auxiliary disk with the destination disk parameter, and the other function is swap with auxiliary disk with source disk parameters. So after after calling these functions, what will happen? This first function will also split divided into another two parts, and and the other function also will be divided into another two parts. Like this, there will as it's not as here the n is not is equal to 0, so again this will divided into two parts. So this works will be done here. So what will happen when the n is equal to 0? The When n is equal to 0, then the function will call as to return all the printing message. and this printing message is movement to solve the Tower of Hanoi problem. So what will to so like all these things that all the function are at the n is equal to 0 position, that's why all the function are calling to return itself. So here the traversal method will follow the in order traversal method, and in here the recursive procedure we are seeing that this is matched with the tree method. So this tree method are will traverse in order traversal method. So what is in order traversal method? We do in the in order traversal method, first of all we print the left child, then the then the root node, and the right child. So here the functions so here the tower of 4 ABC, that's the last level left child will be the A to B, because here the source is A and the destination is B. So our first move will be A to B. The second move is A to C because it's the root node of A1 ACB, because it's come from the 2 ABC. Then the right child, that is B to C, and after the move the A to B move will show, and then C to A, and like all the things the and then C to B, and then A to B, and then A to C, and then B to C, and then B to A, and then C to A, and then B to C, and then A to B, A to C, and last of all B to C. Here we do what? We just printing the message to move a disk from source to destination, and here uh, every printing message the source is the first and the source is and the first disk is the source disk. If we see at the tower 1 CBA, here the source disk are C, not A, and the destination disk here is C to A. So that is the that is the procedure of recursive tree here. So let's check our solution. If our solution is wrong or right, let's check it with the live game. So here the moves are given. Here are the moves are given. That is A to B, A to C, B to C, A to B, and that's so on. So let's follow the instruction to solve this problem, and let's check if the solution is going to take to solve this problem with minimal moves. So at first we have to move the first disk to A to B, A to B, then A to C, then B to C, and that is the solution of number 2. Then again A to B, then C to A, then C to B, and then A to B. And here we are seeing that in our auxiliary rods the number 3 disk solution are slotted here, and then the first disk and the disk of first rods move from A to C. Then we have to move the disk B to C, then B to A, then C to A, and then B to C, then again A to B, then A to C, and the last, the final disk will move here, and we have will we successfully solve this problem with the following with we have successfully solved this problem, but that is not the minimal move. Look here, that is the move we have taken, about 16. So what will be the theory to check if our solution is done with minimal move, that we have seen at the previous slide, that is about 2 to the power n minus 1. So here for 4 disk, the 2 to the power n minus 1 equals to 15. So that is not the minimal actual solution. So let's do it again. So let's move, it is A to B, then A to C, then B to C, then A to B, C to A, C to B, A to B, A to C, B to C, B to A, C to A, B to C, A to B, A to C, and the final move goes on to B to C. And that's just see that we have taken about 15 moves to solve this problem, and this is the this match with the minimal number of moves condition. So we can say that that is the actual solve in this problem. So with this idea we can solve any number of disks. Just we have to memorize the idea that if we want to solve the n disk problem, we have to make sure that we just solve the n minus 1 problem in previous. If we can solve the n minus 1 problem until the 0, we can solve the whole problem so easily. So that's it from me, and I'm Muhammad Robul Islam Shanto, and that is my contact information. If you have any other further doubt in this topic, you can contact with me with this information. So that's all from me. Hope you have a informative sessions with these video tutorials. That's it. Assalamu alaikum everyone.